Greetings and happy January, February 2022, everyone. This is a continuation of our CSTI Science and Culture at Somo series. The original webinar was filmed on December 16th, and then there was some discussion about how to, in 2022, focus on making our webinars more action-oriented. And instead of just presenting information, looking at ways in which we could drill down into frameworks, but not just frameworks, also activity plans that can be implemented and inspire others to do the same. So there will be the focus for what is shared in terms of this particular Odsomo webinar will be the developer perspective from Haas Consult. And there will be also materials shared that were prepared by Muda Design and Mambo Heritage that will be in the participant materials. And from there, as we move through the year, we'll start figuring out where it is others would like to gravitate towards. For this particular approach in terms of, we have been studying biocapacity, and what we want to present at CSTI is the fact that biocapacity is not something that is abstract and ethereal. It is scientific, and yes, there's a lot of research behind it, but it can also be implemented in real estate development. And the Anaki model in Karen, which is done by Haas Consult, is the sort of first time we're seeing within Nairobi this resurgence of looking at what were previously called garden city models, but this is now looking at a more residential scale, more modernized scale. There's also need to start figuring out how, if we're going to be true to the Sustainable Development Goals, how do we make such spaces the type of design that is prevalent, even if you live in a lower income community, or if you live in a very wealthy community, you don't have lower standards of aesthetics or biodiversity and landscaping just because you're in an urban setting or in an informal settlement. There should still be a lot of abundance of design and beautiful flowers and trees, and not just one type of tree, but multiple types of trees. And in some cases also micro parks in which you can bring wildlife back into those spaces. Now, the economics of what we're talking about, the reality is that to pioneer these models, it does take sort of the finances available to luxury developers and high-end developers because these models are not yet necessarily standardized. You know, there's not a standardized, optimized square foot box that you can say it's going to cost this much. In the beginning, it's a lot of what we call exploratory design, exploratory implementation, and you get it right, but as in any manufacturing process, the first prototype or the first set of products will inevitably be more expensive than as you be able to sort of mass replicate. Think of solar panels. The first few solar panels were extremely expensive, and now we're even having affordable solar panels that people can install in their houses for just lighting. And then you have the larger scale model, which can be installed for manufacturing. At one point, manufacturing with solar was cost prohibitive. So in that sense, we're starting by showcasing luxury design, not because we want to be exclusive, but because we know in terms of unit cost of production, there's going to have to be some kind of adaptation of these larger, quote unquote, and this is a 20-acre, I may not be looking at, sorry, might be off on the dimensions, but it's a residential space in which the models that fit will also require landscaping and maintenance services to be able to maintain the aesthetics of the gardens as they were designed. Once we understand that, we can then take small pieces of that and see where those smaller pieces can be adapted in other places and other spaces, and how to integrate that into more affordable housing design models where there might not be the ability to pay for a lot of landscaping and maintenance services, or there might be a need for community instead of professional landscape management services, which then might require less complex biodiversity in terms of the design of the model. So with that long preamble, I'll go into explaining what it is that we have here with fractals. Trying to move the slide. There we go. So fractals have been around in African cultures, and this is Professor Ron Eglash at University of Michigan School of Computing has spent a lifetime bringing out the fact that the design of fractals spaces or fractal crafts in African culture has a unique pattern. So to bring that to your understanding, what we're trying to show here is when you look at a kente cloth, when you look at a kuba cloth or mud cloth, those immediately are evoked in the human psyche as being authentically African. You know, you go to Africans and to find these, and of course, that whether it's Ghana or Nigeria or depending on the region, you know that there's a particular area or group of people once you get into a country and within the African continental space who are known for producing these types of designs. Now, the aspect of that, what you're looking for when you say fractals is no different from the mathematical models of fractals that were brought about by Mandelbrot. And that was looking at self-repeating shapes. As you can see here, you have these cross designs here within the kente cloth, and you also have repeating intersections here. You can call them crosses, you can call them squares, but they repeat, and you start finding a lot of nested patterns. And you can see that, and all here you have triangles, and you have some smaller here, some trapezoids here. This one might be easier to see, a lot of nested triangles here, and self-similarity. So you don't think, if you stretch the kente cloth, you're not going to start thinking this is a circle. It's going to pretty much stay in that shape, even if you make a larger or smaller mud cloth or kente cloth, those shapes are going to be pretty much the same. And they're not just present in fabrics or pottery. We find that there's deliberate use of fractals in the vernacular architecture and layout of, this is a village layout, looking at Lion's Paw. It's the way, basically the village layout resembles if you could fly above from the sky and look at it from a helicopter at a time when they were building these. Of course, they didn't have helicopters or airplanes. This was pre-colonial era. what you see is the ability to create on-the-ground designs that anywhere you look historically for the way in which a Maasai village is laid out, you tend to see this bear's paw formation. And that now proves that there's a deliberate use, because if you're going from Maasai, of course, were nomadic and they traverse different countries across Africa. And if you're looking at the fact that then how is it that two Maasai clans in different countries designed their village in exactly the same way? So it's not that this was something that was brought in by colonial masters who taught people how to do this, or that there was no advanced knowledge or advanced design before colonialism. It was there. It just hasn't been brought forth in the formal literature as a recognition that in the pre-colonial era, there were advanced forms of planning and design and architecture in different African countries and cultural groups. Now, this is looking at more Northern Africa, where you tend to see more of the formal literature focusing on saying that there was civilization, Morocco and Egypt and Northern Africa. Those areas get most of the literature recognition as having had these types of intricate designs, not because they didn't exist in other African countries, but they weren't documented as well as the ones that exist in Northern Africa. So here you see different types of rotation and reflection. So you see the reflection of the circle and concentric circles and bigger concentric circles and smaller concentric circles, and reflecting across the space in different tile shapes. Now, when you see this again, you immediately recognize that this is a Moroccan tile formation. It doesn't strike you that if I said the Kikuyu or the Luo or the Kalenjin, whether or not you knew about African culture, if you're familiar with this type of sort of mosaic style, your mind would gravitate to Moroccan tiles and not necessarily Eastern or Southern or Central African styles of tiling. So here you see, in terms of looking at building facades and wall paintings, or the design, the exterior, what you put on the exterior of your wall, you find fractal shapes. This one's from Burkina Faso, the Gurunsi cultural group, ethnic group, depending on how you prefer. Their designs have multiple fractal shapes, and they're also deliberate. So if anywhere and you ask around, those who are in Burkina Faso would tell you this is specifically a Gurunsi design. Think about the paintings. If you have Western or European frescoes, or the way in which you have tiles looking at clay tiles, or looking at just plain painted walls, the aesthetics are obviously quite different. So there's, in Western designs, there's more homogeneous colors and homogeneity of shapes as the preferred aesthetic in terms of the exterior wall or interior wall. Whereas here you can see that it's a multitude. Those probably look like maybe they're kola nuts and different types of shapes and symbols that are coming through. And you see also the reflection of triangles. Instead of the previous one, we saw a reflection of circles on the Moroccan. Now we see a reflection of triangular shapes. And the reason for studying that is that if we're going to say that we want to bring cultural heritage, and for those of you who don't know about the Center for Science and Technology and Innovations, we are a UNESCO Associate Center. We are a nonprofit and registered as a trust in Nairobi, Kenya. And so when we study science, we do not study science void of the cultural background and cultural heritage in which the science develops. This being said, art is part of science too. The way in which we've been seeing the different shapes yes, they look like art, but they're also the actually trigonometric shapes that you can put. This is an Excel spreadsheet, and you can look at the different types of trapezoid, parallelogram, triangle, and look at them in planar geography, and then start to find intersections of slopes and lines and angles that can be related back to the sort of rhythmic pattern. So when we say there's a rhythmic pattern, perhaps the person doing the design on the wall, or just like anywhere in the world, if I take somebody who's doing embroidery and ask them, what's the calculus of your embroidery? Most will not be able to answer, whether Western or African or Asian. But if I say, what pattern do you use to do embroidery of flower petals? They'll show me the patterns or the stencils that they're using for flower petals. So to bring back cultural heritage into African architecture and African design, and sort of bring back that sort of identity healing back into the design of spaces in African cities and rural areas, and just built space and built environment in general. What we have to do is bridge the gap that's missing, which is to be able to retrace and look at the patterns that have historically existed and correlate those to formula and also the science of materials that can then be translated into industrial production systems. And again, in the beginning, the cost of this would be high because there's a lot of exploratory and original research that needs to be done. Now, why are we looking at doing this now, apart from the Sustainable Development Goals and the need to revive cultural heritage as part of Sustainable Development Goals and be inclusive? There's also a possibility of innovation. And what we do know about climate change is that the patterns of climate change and climate variability effects, you hear the term microclimates, but even within the microclimates, there are patterns that are fractal. And to give you an example, this is methane and methane gas bubbles trapped in ice. And you can see, interestingly, almost looks like different floating circles, and you have cylinders, and there's, you would never see this with the naked eye, but when you look at this in terms of at the microscopic level, and that's another characteristic of fractals, that you don't readily recognize the shape or the design until you start studying it. And sometimes in science, the ability to study depends on your ability to detect, which depends on the equipment, surveillance equipment you have. So once we start paying attention to that, we start recognizing that there's, it almost looks, maybe you think of a lily pond, or some others would think of steps going up, but there's definitely repeating. So if we start measuring the diameter and circumference of these different circular condensations or trapped bubbles of methane gas, we can start figuring out what's going on here. Why is this shape the same anywhere you have methane gas trapped? Or if it's in a warmer climate, would methane gas have the same type of shape and distribution in terms of bubbling, if you could somehow congeal hot, because methane gas is volatile. Could you sort of freeze frame that moment in a warmer tropical climate and see the same pattern? That would start to help us understand a lot about climate change activity. And it also helps us start to understand biocapacity. When you look at, so here on the left, you have a human lung. We talk about trees enabling us to breathe. And on the right, you have a tree with this bronchial pattern. And in our lungs, we call this distribution of veins and capillaries a bronchial pattern as well. So we haven't even realized that in our language, we're repeating a lot of the same information in terms of bronchial tubing, bronchial patterns. And we talk about trees being the lungs of the earth. And that's one measure of biocapacity. And for those of you know or have been exposed to studies of what happens when you feel you're a frequent smoker and you get black lung syndrome because the sort of tar and pollution accumulates in your lungs, the same can happen in trees. You may not see it, just like you need an X-ray machine to see tar accumulation in lungs. You would need special microscopes to see how chemical pollutants are accumulating in trees. And we do know that even things like methane, it's not just carbon dioxide, but methane can accumulate in trees to the point where trees become flammable. So hopefully that begins to put in context the sort of, when we say climate variability and climate change are caused by human activity, and especially different industrial processes. Think of smoking as a human activity that deposits pollution in lungs, and smokestacks are a human activity that deposits pollution in trees and soils. Here we also start looking at, we talk about viruses, and of course we're in the middle of this COVID-19 pandemic, and trying to understand what are the triggers and how is it that the viruses come to be, and taking away not only just the discussion about zoonotic diseases and how they transfer from animals to humans and vice versa. We also need to realize that the brain neurons, just like computer networks, have biochemical reactions, and those stimulate different functions within the body. So when the human body is exposed to different levels of chemicals in the air or in the water or in the food that we consume, those chemicals do affect the biochemical neurons and the synaptic activities that go on in our brains. And there's a lot of alarm about whether or not autism and vaccines are related. The science points to a weak relationship between autism and vaccines, but where there is emerging research in terms of what might be a stronger correlation is the exposure to different types of chemical toxins. For example, lead is a neurotoxin. And if you have lead paint or lead in children's toys, that could, there's not going to necessarily be anything that will immediately tell you your child has been exposed to lead. But the effects, unfortunately, on the neuro development of children and also of adults, even with adult populations, high exposure to lead has been correlated to increased violent behavior and aggression. So, and this is because of changes in neurosynaptic activity. So one of the things as we're trying to, this is the Nairobi, new Nairobi Mau Expressway, and it's been development herald and also by environmentalists and conservationists quite controversial in terms of the amount of green space that was eliminated in order to work on the construction of that. You obviously can't have trees growing while you're building the highway landscape, but there are parts of the landscape that, I mean, you can't put trees in the middle of the highway because then the cars wouldn't be able to go through there. So depending on your level of preference or your standards for what constitutes a green city or a garden city, if you want high level of biodiversity and greenery, this space here would be a net loss in terms of looking at biodiversity and looking at the biocapacity of the space, especially around here. Now, the reality is that we can't eliminate human activity. So the flip side of argument of that is that this is the time when Africans across different countries now have the ability to catch up in terms of modern technology, and putting a clamp on this type of industrial growth and human activity will also impede affordable industrialization in terms of high-speed connections and transportation and things of that nature. Yes, for example, electric cars exist, and it would be really great to have a highway where all the vehicles are electric instead of petrol or diesel. At the same time, if your monthly earnings are about $200 a month, your chance of being able to afford a Tesla type vehicle are very slim to none. So it's the debate about how to be inclusive in the way in which we bring in advanced technology and modernization and enable those in different African countries to leapfrog has to be contextualized by the reality that right now the type of safer and quote unquote green or more sustainable technologies and equipment that exist are high-end luxury items in terms of the average individual person or household budget, and particularly in areas where there are individuals living on less than $1 a day or less than $5 a day. We still haven't, no matter how small we make a car, even if it's a two-seater, there's still a choice of food and hospital bills and school fees versus being able to afford even an affordable quote unquote electric scooter. So these are the hard-nosed choices that need to happen and need to be debated. And at the same time, there's also a need to recognize that whether it's governments or whether it's people, we have to come together and figure out how we ensure that economic development happens in a way that's affordable for everybody. So that's why some of the ideas about carpool sharing or resource sharing are coming up, because that's one way of group ownership, is one way of saying that things can be more affordable than each person having individual ownership of something, as one way of looking at ways in which those affordability hurdles can be jumped over. And so with that, it's the beginning of 2022 and still probably a little bit abstract in terms of the discussion, but in the next presentation, you'll see from Haas, you'll begin to understand the types of decision-making that take place. Goal being to understand that the decisions are not easy. It's more of a deliberate choice in terms of once we're committed to moving in the direction of more sustainable development and reducing toxins and pollution in the environment, then we start forcing ourselves to make choices that in the short run may not make the most quote unquote practical or profitable sense, but in the long run, you start getting gains in terms of health savings and energy savings, also reduced cost of environmental remediation and things of that nature. And with that, we'll transition to the next presentation.